All right, so yesterday we were here. We were talking about these graphs. Now we are about to graph all these inverse trig function graphs. So the way we will approach these is to first write down the restrictions. It's very important that you know all the restrictions. So you can take a mental picture of this table right here. So cosine, secant, cotangents, they are quadrants 1 and 2. And then all the other ones are quadrants 4. And I will let you dive into my mind. I will share with you what's in my mind so that I know how I am correct and how you know that you are correct. So to confirm yourself that you got the restrictions correct, so first think about the cosine graph. Ask yourself, do you have a picture of a cosine graph? And you have an option. You have a A and B choice, 2 choices only. Quadrants 1 and quadrants 2 versus quadrants 1 and quadrants 4. So if you load up your cosine graph in your head and you're like, wait, hold on. Is it quadrant 1 and 4 and 1 and 2? It's got to be 1 and 2 because you need to have a 1-to-1 function. If you take quadrant 1 and 4 for cosine, it's not a 1-to-1 function, so that's going to be a problem. Okay, so that's how you can confirm yourself with these quadrant restrictions. Our goal is to make sure that after the restriction, it is a 1-to-1 function. So your graphing, it's very necessary. Okay. All right. So after you write out all these restrictions, then you can list out some nice points. Now, this morning I got some students asking me, how do you know what points to list out? You would only use the nice ones. You know, the angles that would give you the nice numbers like 0 or 1. So for cosine x, I'm gonna, well, since it's quadrants 1 and 2, so I use 0, pi over 2, and pi. I got those 3 values. I put those 3 points on the, well, then I know the inverse would be these x and y swapped. Put those points on the graph. And here. I addressed this question on Monday, well, yesterday, no, last Friday, that how do you know the curve is drawn properly? How do you know again? How can you check, confirm yourself that your graph is drawn properly? You rotate the page 90 degrees and see if it looks like part of the cosine graph. It should look like a cosine graph. If it doesn't resemble a cosine graph, then you know something is wrong. Okay. So now let's go ahead and look at inverse sine. So we know it's going to be quadrants 1 and 4. So we go from the end of the quadrant 4, which will be negative pi over 2. Again, when we say quadrant 4, it's negative pi over 2, not 3 pi over 2, because we are taking the values to the left of the y-axis as we graph it. So we say, all right, these 3 x values for the sine function. We just go ahead and write down sine function, sine x right here. So these 3 x values would give us a nice y value. So what's sine of negative pi over 2? Sine of negative pi over 2 is negative 1. Sine 0 is 0. And sine of pi over 2 is 1. So again, know the unit circle values so that you know what I'm doing, so that you know what you're doing. If not, it's going to be very foggy. So go ahead, plot these points. Okay. Plot these points, and then graph it. And again, To make sure that the graph is drawn properly, you rotate your paper 90 degrees and see if it's like a cosine graph or sine graph. Okay. Any question about this one? So ask yourself, do you think you can sketch these two graphs with ways to confirm yourself? Okay, with ways to confirm yourself. And my way of confirming myself, give a few values. Okay. Give a few coordinates, then we can have some good values. All right, right here, we have tangent inverse of x. So let's think about tangent x. We have quadrants 1 and quadrants 4. So we have some nice values for tangent. So let's go ahead from negative pi over 2. And I'm going to go to negative pi over 4 as well, because that's going to give us a good, nice number. All right, so I'm going to give you a moment to write out these values. Okay, so tangent of negative pi over 2, what would that be? What is tangent of negative pi over 4? Tangent 0. All right, what is tangent of negative pi over 2? It is. It's undefined. So as tangent of pi over 2. Tangent of negative pi over 4 is -1. Tangent 0 is 0. And tangent of pi over 4, it's 1. So you will swap them. So you have a point right here. You have a point right here. You have a point right here. And what about those two vertical asymptotes on the tangent graph? Well, they would now become the horizontal asymptotes. Okay. So again, if you rotate it, it should look like one of those tangent graphs that you have drawn in the past. Okay. Now, all right, next up, cotangent. Well, cotangent, if you can sketch the graph right there, it's quadrants 1 and 2, so you can give yourself some values there. So we have quadrant 1, and then quadrants 2. Right, again, give yourself a couple of seconds to write out the y values for cotangent x. So then you can plot out what the what tangent or what inverse cotangent x would look like. Okay, so you have your cotangent values. You can plot the points pretty easily. All right, last two, secant inverse and cosecant inverse. I hate them the most. So I need to find a way to figure my way out. So I'm gonna have some secant x values. It's quadrant 1 and 2. So I would look at some 0, and then pi over 2, and then pi. And well, if it's secant x, that means I can also think about this as 1 over cosine x. So that's going to help me, okay, figuring out the values. So I'm like, okay, what's cosine of 0? Cosine of 0 is 1. So so you have 0, comma 1. And then cosine of pi over 2 is 0. So 1 over 0 becomes undefined. And then cosine of pi, it's -1. So 1 over -1, it's -1. So that means we have a few points here, 1, comma 0 for the inverse. All right. And then we have one single horizontal asymptote here at pi over 2. And the way you draw the graph, it's that the point's gonna start and then it's gonna lean toward the asymptote. It's a little bit weird looking, but once you rotate it, you'll be like, oh, that's just like the good old secant graph. Okay. All right. And number 6, cosecant x, cosecant inverse cosecant x. So I'm going to ask myself, what is cosecant x? Well, we have quadrant 1 and quadrant 4. So we will go from negative pi over 2, 0, and pi over 2. And then we'll investigate what the values are. And since I'm thinking about, well, it's cosecant x. So we can think about 1 over sine x. 1 over sine x. And if it's negative pi over 2, so think about, what is sine of negative pi over 2? -1. 1 over -1, it's -1. And then sine 0, it's 0. So 1 over 0, it's undefined. So now you have the horizontal asymptote on the x-axis. And it's got the points -1, comma, negative pi over 2, and 1, comma, pi over 2. So it's going to lean closer towards the asymptote. So but you can only explain the shape, the weird shape of the graph, by knowing these secant or cosecant values. If not, I would say it's just hard to fathom, to understand, to make sense out of these weird looking shapes. Okay. All right now, so these are the graphs. Please do know them for tomorrow and say goodbye to them, or just have a temporary timeout for them. The kind of questions you will see tomorrow will be like on the very last page on your day 2 packet, like the last, I mean, like this one, all right, or from day 1 packet, something like these questions. Only one transformation, only one transformation. So if you can grab these, that would be nice. Okay, so we're like, so let me walk you through the whole thought process. Well, just like any other graph, you should be able to tell the transformations easily. Like this one is +2, meaning that moving to the left 2 units. Now, what is the first thing that you should do when you see this? Sketch. Y equals to arc cosine of x. Okay, sketch the parent. There will be plenty of time tomorrow if you know the other questions, which we'll go over them shortly. Okay, and again, that would have a lot to do with your familiarity on the unit circle values. So first you will sketch the arc cosine x. And make sure you know the restriction. What's the restriction for arc cosine or inverse cosine? Quadrant 1 and 2. So you can quickly populate the numbers in your head, or you can write them down. So you think about for cosine 0, 1, right? Cosine 0, it's 1, so therefore 1, 0. And then the next value will be power over 2. What's cosine of power over 2? Let's say it's 0, so that means the next point is 0, power over 2. And then you have pi, -1. Cosine of pi, it's -1, so you switch the values. So you have this graph as your inverse cosine function. So just like what we did earlier, just make sure you do it faster. And then now we say what? We say, oh, please move to the left 2 units. So 1 becomes -1, and make sure you are paying attention to the scale right here. Okay, so 0 becomes -2, and it would be -2, power over 2, and then -3, pi, and that's it. That's it. Okay. So make sure you sketch the parent function first. Don't overload yourself. It's not a good time to overload yourself. Okay, yes. All right, so now you can try number 33. 33 is moving to the left 1 unit. So I would do a very quick sketch. Okay. Now you can make this whole sketching process a little bit faster. So you could be thinking like, wait, hold on. I remember there are 2 asymptotes for tangent, because there are 2 asymptotes for the regular tangent. So I know there are 2 asymptotes for the inverse tangent. And you know some values. You know that it's 0, 0. You know that at 1, there will be pi over 4. And -pi over 4, that's also a value of -1. So you know it's going to be like this. And now we are moving to the left 1 unit. So now the asymptotes are at pi over 2 and -pi over 2. So pay attention to the scale on the actual graph. So draw your vertical asymptotes here. Don't draw them at the wrong place. So that's a 0, 0. Hold on, we're moving to the left 1 unit. So right here. So all I'm asking you is just something like this. If you can give me the 2 asymptotes, if you can give me this point, I give you full credit. Okay. So we are just moving to the left 1 unit. So make sure you know how to sketch the graph. Sketch the original parent function. So that would be a good thing to do tonight. Just making sure that you can sketch all these shapes properly.